Hey everybody, Shawn here from the Automation Blog and School, and in this episode of the Automation Podcast, I meet up with Mikel Ayani from Simumatik to learn all about their excellent and affordable simulation software. Mikel, thank you for coming on the Automation Podcast today. Really appreciate taking time out of your busy schedule to come on the show and tell us all about your company. Now, before we get started and dig into your presentation, would you mind first telling our audience a little bit about your position in the company?
Yeah, hi, Shawn, and thank you for inviting me to this podcast. So I'm automation engineer. I'm from Spain, 40 years old. I've been working within industry and education the last 15 years. And since 4 or 5 years ago, I'm the founder of Simumatik. I'm the CEO just right now. And I'm leading the team through the development of the platform. And here we are. I'm very happy to show you about our product.
Yeah, I'm looking forward to learning more about what you guys do. So please jump right in.
Yeah. So in Simumatic we develop this emulation platform, what we call emulation platform. But you know how it is right now with the industry. We are through this industry 4.0 transition, digitalization, global market transition from to a more flexible production and so on. So with our product, we want to help both the industry and education in this transition. And how we do that? We do that through our emulation platform. So we want to help companies in this digitization transition. We want to give them flexibility to work more remotely and more flexible. We believe on cloud services and the potential we have right now in the cloud computationally, and even the flexibility that allows saving data in the cloud. But mostly, I think it's very important for Simumatic. We believe in more sustainable industry, and we believe that with our product, we can help companies to become more sustainable. So how we can do that? We do that through digital twins, or we prefer to call them emulation models. So with our platform, both industry companies and education institutions can build models of their systems. Okay, for an industrial company, that means that they can build an emulation model of their machinery, and they can use it for virtual commissioning. They can use it for developing new prototypes. They can use it for operator training and so on. Many different applications. And in education, they can use it as well to create digital versions or digital models of their labs and provide the students with a more flexible way of practicing. So they don't need to queue to get access to physical labs and so on. So basically, yeah.
Now, I
Go
just
ahead.
want to interrupt for our audio-only audience. What we see on the screen here is for industry, you see it looks like a large palletizer being simulated with a robot loader unloader. And, that is just one of many examples you see in his slideshow. They have conveyors, lots of robots, lots of different machines and processes. But on the education side, I don't think a lot of people realize this, that, through the pandemic, students, with remote learning, didn't have access to the expensive, very functional trainers that a lot of colleges would have, where they would have a PLC and an HMI and a little conveyor and a pusher and an actuator and different products going through with different sensors. And so, it's hard to learn, for especially some people, it's hard to learn without that interactivity. And so here we see on this slide a virtual trainer, right? We see a model of what you would find on one of these training companies' websites where they have a conveyor and a
Yeah.
pick and place machine. And now that it's been virtualized. So the student can still do his training, but he
Mhm.
doesn't have to be in front of the actual physical piece of training hardware. So I think both of these are very intriguing to me, at least to me. And I just wanted to take a moment for our audio only audience to kind of go through that and explain what we're seeing on the screen.
Yes, yeah, I understand. Yeah, and I agree. I mean, the pandemic has been crazy. It has changed the way we work and the way we teach, and we actually were forced somehow to release our product earlier than expected, just because the request we had from the educational market. So we believe that there is a lot of potential, and if we want to transform the industry, we need to get more educated technicians and engineers that know that this technology is available. So for us, it's very, very important that we can start using these kind of technologies in education. So yeah, how you use these kind of models. In the slide, I'm showing the common process, how you go from the design of an industrial system to the commissioning, and you do it through different phases. So first you design the solution, then you do the development work, then you build or make the construction of the system, and finally you do the commissioning, where you put the hardware and the software together, and you make sure that the system behaves like expected, and and fulfills the requirements. So traditionally, virtual commissioning has been something to replace somehow the commissioning part or reduce the commissioning part, but we see a transition where virtual commissioning models or emulation models like the ones that you can build with Simumatik can be used almost from the very beginning of the process. So you can build a model almost in parallel with the design of the system. And you can use the model to validate the design, to support the development of robot programs, PLC programs, and so on. Give that tool to the programmers, and then use the time you have before while the system is being constructed or built to do the virtual commissioning and reduce drastically the real commissioning time.
Yeah, and I want to throw in here. I mean, we know the term digital twin. This is one of the hot topics in our industry right now, and there are a lot of players trying to get it right. But from the PLC programmer side, we know that typically mechanical side is usually late, very late, and we
Yeah.
usually are in crunch time to get everything programmed and done. And I know so many so many controls engineers who end up having to work late nights and weekends because
Yeah.
you just can't speed up mechanical. It's finished when it's finished, and then now the product has to leave on a truck on Monday morning, and so the controls engineer is the one who gets stuck working all weekend to try to make up the time that was lost because of, just things that happen mechanically. You can't. So by being able to test your code out, using a digital twin, using a package like yours, it can really save you a lot of time. Because I myself remember filling in for a control engineer and just sitting there actuating, conveyors and pistons and all kinds of stuff, so the mechanical guys could finish their checkout, and the programming guys could start working on programming the system. And if you had a virtual system to work on, you could test out and flesh out your code so much earlier in the process. So I just wanted to throw that in there.
Yeah, I mean, I'm an automation engineer. I've been doing commissionings, and I know how tough it can be when you are traveling abroad, when you are away from home, working really long days
Hmm.
to get these machines or systems started. I know this technology will give a lot of, or gives really uh, life quality to commissioning engineers or automation engineers, because the reasons you are giving, they can do most of their work from the office and reduce the traveling time, the staff commissioning times, and so on. So yeah, we believe we can help a lot of people with these kind of tools. So yeah, basically, I'm gonna end the company presentation with this slide. What we offer, uh, if it wasn't clear, what we developed at in Simumatik is the platform where our customers can build their own systems. Uh, but we can also help them to build their virtual model. So we have a subscription-based model, business model. So companies and educational institutions can subscribe, and they pay depending the amount of seats they have in the organization. So we have very similar business model to GitHub and these kind of platforms where you build an organization and then you invite your teammates to this organization and they occupy a seat. And depending how many seats you want in your organization, you pay more or less. And as I mentioned, we don't leave alone our customers. We believe or we know that most of them are new with this technology. So we support them through the first projects, or what we call the pilot projects. We help them through the first modeling. We help them to validate the model to make sure they can run their programs against the model and so on. And of course, we provide support in email support, telephone support, or we have our forum and our academy site. So this is how we interact with our customers.
I think you also have for engineers who may want to before approaching management with a subscription. I believe you have also have a lower cost, like a
Yes,
personal subscription. So if
yes,
there's an engineer out there who wants to try it, it could be an instructor or an engineer. They're like, look, I really need to try this myself
yes,
after hours, maybe at home. Make sure I understand what the capabilities are before I approach management with a subscription that you have a lower cost kind of what I looked at it as a great way for somebody to
yes,
say,
exactly. Yeah.
let me kick the tires around a little bit before we make a big commitment for all of our engineering staff. So, and is that correct?
Yes, yes, and you are totally right. The aim of that individual subscription is to offer an entry door. So anyone that from hobbies, interest, people interested in technology, engineers that just want to give a try, weekend or wherever, or teachers, we have that individual subscription. It's just 25 euros per month, and you get full functionality. You can unsubscribe whenever you want, so you just commit to a month, and you can play with all the features, create your systems, play around, and then if you think it's worth, then you can talk to your boss or whoever and subscribe for the organization. Yeah.
Excellent.
Hmm. So yeah, that was my first presentation, and then I just wanted to show some other slides because I believe uh, is what I mentioned in the beginning, that we really need a change in education to promote this technology. I think the benefits of using emulation technology or digital twins is clear. Many people have seen it, even if not many people is using it. It's clear that you can save a lot of time and effort and be much more sustainable creating new projects. But we need to start from education. We need to start from changing the way we educate and giving also that flexibility in education to the students. So I wanted to show you just some other features that we have in Simumatik that, of course, they are very interesting for engineers, but and technicians, but with a more educational perspective. Any questions so far, Shawn?
No, no, go ahead.
Yeah. So yeah, let's. I think I already mentioned, but something quite pretty unique with our platform is that it's cloud-based. That means that everything is stored encrypted in the cloud, so you can basically start working in the office, move somewhere else, keep working, and as long as you have a web browser, you can access and work with the platform. There are two ways to run the models. Actually, you can run the models in your own computer, but we offer also the opportunity to run the models in the cloud. So basically, it's like a video game. You can run the game locally, or you can run the game on the cloud. And that allows also people to collaborate in the cloud. So you could be building your system in the cloud, and I can connect to the same workspace, what we call the workspace, and we could collaborate and build a system together or even commission it together. So that is, we believe in the cloud, and we believe that that's the way, that's the place where power, computational power, will be in the future. And that is in our mind for scalability. We are developing this platform, having in mind that our customers should be able to build from very simple systems to huge systems, maybe complete production lines. And for that, they will get the computational performance from the cloud. So those are just some insights. And I'm going to show this video where I want to show, this is a video that I can actually share from one of our customers, industrial customers. I don't have many videos I can show from industry because as you can understand, there is a lot of IP there. I'm going to reduce the quality just to show. So this what we see is a hot press, which is fed completely automatically. So the parts that are going to be pressed are being heated before. So they are introduced in an oven with a crane. We are seeing the crane now moving in the real crane moving in the movie, and the parts are introduced in this oven before they are pressed. So in this project, what we did is that we create a model that we are going to see now, which can run with the exact same PLC program that the real system is running against. And in this case, we use this to optimize the PLC code and even the cycle time, and study ways to improve the entire process. So what we are seeing here is actually one of our guys with the VR goggles inside the model and interacting, pressing the buttons and so on, which is also a out-of-the-box functionality with Simumatik. If you have a VR set, you can just set it and go inside the model and interact with the different parts. You see the model looks like the real one because we use the 3D CAD models from the real machine, and then we give it live inside Simumatik with the tools that Simumatik offers. And as we are gonna see now, what we introduced it in this project was this big KUKA robot that does not exist in the reality, but this customer wanted to check, okay, is it worth to add a robot here so we can avoid having, for example, an operator to feed the machine. And this is something that if you want to try in the real world, it's going to cost you money. You need to order the robot and so on. But here you can do it almost for free. It takes just a few minutes to introduce the robot and add some code. In this case, we program the robot, we connect the robot with the PLC, and we could see that we could interact the PLC between the PLC and the robot, and everything get everything synchronized and working. So somehow this video shows different applications that you can do in industry, from debugging or improving PLC or control logic. You can do, as we can see now, kind of operator training. You can jump into the model, play like an operator, test the machine. You can generate faults in the machine and train operator to solve these issues. And as we saw at the end, you can add more stuff, or you can upgrade the system and test how it will impact in the final result.
So you said some important things here. First of all, this animated 3D model, you can input your SolidWorks, I'd imagine, into your software.
Yes.
Okay, and then
so you start introducing the 3D part of the model, and then you bring it to life with the tools we offer in Simumatik, like kinematics, physics, and you model the behavior of each part in the model.
now the next question is, you said you actually then tied this to a real PLC or a PLC sim,
Yes,
this isn't some script inside your software. This is actually getting live values from a PLC.
exactly, exactly. So this is not an animation. What you basically build is a model of the hardware in your system, all the mechatronics, all the sensors. And what happens is that the model connects to your PLC, and it's gonna read and write in the memory, so you can execute your PLC code as in the real system.
And you can even add a small control panel with
Yeah,
push buttons and switches and put on a PCVR and actually see it from a first person perspective and actually press those buttons like for operated training. Am I
exactly.
understanding that? Oh, wow.
Yeah. So now you see the real operator doing a fake empty cycle, pressing the buttons and so on. And now we are going to see the VR operator. So one of us with the VR goggles doing exactly the same. And it's against the same PLC program. So
Now this
now,
isn't this is like a third person perspective, but the
yes, yeah,
person represented by the green, he's actually wearing the VR headset.
yes, exactly. Now what we are seeing is from the third person perspective, but this guy there. So now the press is going down, and I mean, it's all this is controlled with in this case, is TIA portal with the real virtual drives and so on. So everything in the model is controlled by that. You can press the button. We don't have all the buttons in that panel, but now you see how the guy is moving forward. He's gonna grab the pieces like the operator was simulating before,
Hmm.
and then you can take them. And this is actually what they are doing in this system. They are feeding and emptying the machine manually.
I see.
And
Yeah.
in this case, we wanted to show, illustrate that.
Now, for anybody watching who's not familiar with VR, you typically don't put trackers on your feet.
Yeah,
That's why the model doesn't look
yeah,
it's not like, he doesn't have a bunch of little white dots all over him and they're not doing
no,
motion capture. You typically
no,
have something in each hand, and if your hands get by your sides, they kind of the headset loses track of them, which is
yeah,
why you saw the hands kind of grow in distance. But that has nothing to do with the software. That's a
yeah.
PC VR thing.
Yes, yes. I mean, you don't have that much information.
No.
The human body has a lot of leads, but with the VR headset, you just have a sensor in the head and two sensors, one in each hand. You cannot estimate all the position of all the parts in your body with just that information.
Yeah, and
So,
usually you're not looking at yourself in VR.
yeah,
You're in a first person view. So it doesn't
yeah,
matter what your feet are doing because you can't see them.
yeah. So of course there is possibility, and we actually have done some research in that area that if you set more sensors in your body, then you can actually do a much more accurate
Yeah.
simulation of your body. And we have actually done together with the university an ergonomics study. So you can record all this data while you are playing as an operator, and then you can post-process all this data to do an ergonomic study, which is in nowadays people is doing that with software that does not have any connection to the PLC and so on. So they are doing this kind of animations to be able to create to generate these ergonomic studies. But in this case, we are aiming to give that use as well to Simumatik. So once you have created the model, you have used it to develop your PLC or robot programs to do the virtual commissioning, train operators. Why not set some extra sensors in your body and actually do some ergonomic studies?
Yeah,
Or maybe that do them even before you are done with the real system, because if you want to adjust the system, it's better to do them the ergonomic study before you start building it. So
yeah, for those who maybe only are familiar with like PlayStation VR or Oculus Quest 2, the PC models allow you to add additional sensors. So you could
yeah,
capture, foot, thigh,
yep,
you could capture multiple sensors, chest, if you wanted to do a true ergonomics. But I don't know that most people would use VR, but it's nice to see that that's an option that
Mm,
you could, hey, after you spend all the time building this up to test the machine out, you could throw a VR headset on and see it first person. That would be great,
yeah,
and maybe even use it later on for operator training. I think most people though will be thinking digital twin. The machine's going to take forever to build. I really want to finish my PLC program. Or like you said in the case of this example, would adding this robot to load or unload, would that increase our cycle times? And how
yeah.
much would it? And what's the payback? Because if I know that the robot will increase cycle times or allow the system to be unmanned, I know what that has on the bottom line. I know how that affects, manufacturing rates. So
Yeah,
that's besides the digital twin, that part is huge as well because it
yeah.
allows you to extrapolate and try things that, like you said, would be price prohibitive really to try. You typically management won't approve buying a robot for a test,
No,
because
no.
they're
I mean,
very expensive.
and that's we come back to the sustainability perspective. All this. I mean, traveling, traveling customers to your site to see your system up and running and so on, or sales meetings and so on. You can actually use these kind of models and invite your customer. They can be abroad. I mean, they can be in another country. They can connect to the model with VR and see the progress. They can see how the commissioning process is going. You can show them. They can interact. I mean, all this stuff, it helps to reduce a lot of traveling as well
Yeah,
in this case.
that's a great point because once you do your first project, now it's done. A lot of OEMs work on the same product. I mean, they may customize it for each order, but
Exactly.
once you do it the first time, it's copy paste and some editing. So, if they add a second robot or they, add three robots or two machines or conveyor, now you're just tweaking your existing setup. So
Yeah,
that's a very good point. And you can use it in your sales presentations. You can use it in your
exactly. Yeah,
brochures.
exactly. Yeah. So yeah, then I just wanted to jump, if we have some time left, and show if we want to go or get there in the industry, we need to start from education. And what we see now in the screen is uh, is kind of related to what we saw in the first presentation. But in this case, we have three stations. That this is, as you mentioned, is one of our partners that builds this physical labs for students. These production lines in very little scale. But basically here you do exactly the same. You connect these systems with uh, TIA portal or any codices or BMR, any PLC programming software that has a soft PLC or directly to a real PLC, and you can use you can show your skills, or you can test your skills against these virtual models.
Now, I think a lot of the viewers, and my apologies to the audio audience, but a lot of the viewers are looking at this, and this is like, hey, I got a machine that does this. It's a pick a place assembler, and it puts things
Yeah,
together. And so you can see the complexity for a system with lots of slides and pick and places and suction pick and places and whatnot. Sensors, there's multiple sensors here and product bins and whatnot. I mean, you can do that inside of this product, but for those who are on the education side, I mean, for me, I teach thousands of students every year,
yeah,
and at least half of them are training on their own at home.
yeah,
And so having something like this available that they could make use of to kind of visualize, it's one thing to have a PLC with some lights and buttons, right? But it's
yeah.
another thing to actually have a system that
Of
you can
course.
try to break, you know what I'm saying, and try different things on. So
Yeah,
yeah, for both audiences, I think this is a good example of how your software works and how it can help those users.
yeah. So I usually say that virtual labs, these are like the selling points or the value added. So it's cost effective. We want to democratize the use of this technology, and you can see now when you have seen these videos, if you can just add a robot, an industrial robot that costs I don't know, thousands and
Hmm.
thousands of dollars with just a mouse click. Imagine how are you democratizing access to technology to anyone? I mean, it can be it can be anyone at home, just a hobbyist or a student that can get access somehow to industrial equipment to train. I mean, how cool is this, and how easy are we doing it? And of course, when you are playing with this equipment, it's much more sustainable than using these virtual labs than the real ones because they don't consume almost energy. I mean, it's much. You saw that press in the video. Running any test against this big press, it costs a lot of money, but you can do exactly the same and tune it in the virtual world, and it's not going to stop production, and it's not going to cost you money. So it's
Yeah.
the same with the labs, virtual labs. I mean, they have no maintenance. I was talking to a customer this week, and they were complaining because the students break the lab every year. I mean, they are putting things together, and then they screw up something, and they are buying parts, spare parts all the time. You can reduce all this pain if your students are working part of the time and most of the time virtually, and then they when they are ready with the PLC programs or robot programs, they go to the real one to show that it actually works, and you reduce all these testing, troubleshooting, and breaking moments.
Yeah, I agree. I mean, I was about to say the same thing. You must pass the virtual machine and get that working before we allow you to test on the actual
Exactly.
physical machine. You know what?
Exactly.
The other thing too, though, is that my youngest son just went through the whole hiring phase. You know, he graduated college and was doing a lot of remote interviews. I could also see companies wanting to use this as a test for, especially
Yeah,
large companies. They
of
could
course.
design their own tests for a potential controls
Mhm.
engineer. Say, look, we really want you to join our controls engineers group. We want you to program this virtual machine that make it do X, Y, and Z, and because we want to feel confident that you have the knowledge and the
Yeah.
capabilities to do that. So I could see it even used in that way,
Yeah,
where
I didn't think about this. It's a very good idea, actually.
yeah,
Yeah.
yeah. So that's a great way to remotely interview somebody. I know
Yeah.
a lot of companies, I shouldn't say a lot, but some companies do have like a handwritten test they have them do, create
Yeah.
ladder logic that will do X, Y, and Z. But this would be kind of the next step to that, especially if you're doing something remote, because you don't want to get you don't want your tests getting out there in the world because then people will cheat. Not, I
Yeah.
shouldn't say
Yeah.
that like that, but the
Yeah.
cliff notes, people will have cliff notes. This is how you solve the test at Amazon or somewhere else.
Yeah.
So yeah, very interesting.
Mm. So yeah, in the then of course in education we meet teachers that have 50, 100 students and maybe just 2, 3 physical labs, and the students are have to schedule time. There is bottlenecks all the time. Again, offering them the possibility to work against the virtual model, it makes everything more effective. And actually, the experience, I've been working in education as well. The experience is that in the same amount of time, you can get more from the students because they have more access to the technology, so they can practice more time. So at the end, they learn more and you get more outcome from the courses. So this is uh, pretty cool. And then, of course, if you want, you can allow the students to create their own labs and play with the creativity. And this is really really cool when you see students that they start learning different languages in PLC. You give them this lab, and then you see them making modifications to this lab because they see it like a game, and they get so involved with the course or the lab, and they start adding more stuff because they get this interest. They are playing while they are learning, and I think that is very important if we really want to get more people studying this kind of stuff, engineering or automation. We need to make it more fun as well, and nowadays kids like video games, and they see this also kind of a video game, but a video game they can program with a PLC, right?
Yeah, I think any controls engineering program would do well to also teach their students how to create a digital twin of a system.
Yeah.
So that's the whole other side of it, is that you're not just teaching them how to do control code, you're
Yes.
actually teaching them how to create a digital twin of
Yeah.
maybe a system that's in the classroom. So, yeah,
Yeah. Exactly.
wouldn't you love to have that on your resume as a new controls engineer?
Yeah. I mean, if we want to have engineers in the industry that are building these digital twins, we need to teach them before they are out there. We need to have
Yeah.
more people with this knowledge. And I totally agree. We are pushing all the time our customers to allow the students building as well and playing around, be creating their own labs, because these students will bring that knowledge to the industry later. So yeah, and this is exactly what we were talking about. We need these new skills out in the industry. So usually the question is, why not use this technology in education? I'm gonna jump this video, and now I'm just gonna show some use cases. So we have been talking about programmable controllers and robots, but you can actually use Simumatic for very basic stuff. We have customers using it for just teaching electricity basics, so just how a relay works, how a motor contactor works, and so on. And for that, you can just build the system in Simumatic. What you digitize is each component individually, and when you are ready with all the components, you can use the ones that we have in our libraries and so on, and the ones that people has published in the cloud. So when you build your own library with all these components, then you just drag and drop them, and you connect them exactly the same way you connect them in reality. That's pretty unique with Simumatic, that we follow the same uh, concepts as in the reality. If you can, we usually say, if you can build the system in reality, you can build it in Simumatic, because basically you are following the same connections. Actually, in Simumatic, you can make the connections between the components, creating the schematics. So you drag and drop the components, then you see the components in a schematic uh, picture, and then you just drag and drop the connections of the cables to make everything work as you want. So you can do it with electrical systems, you can do it with pneumatical systems and hydraulic systems. And again, the principles are the same. Each element is a component, a cylinder, a button, or a valve, or whatever, and then you just make connections between them. If you miss a connection, the system is not going to work as expected.
Mm.
So, uh, and this is part of the building process. If you are you can build simple systems where you don't have a PLC, but basically when you jump from this to a PLC, the only difference is that you add the PLC as well as a component in Simumatic, and then you do the connections from the PLC output to a solenoid, or to a pilot lamp, or motor contactor, or whatever, and then you take the sensor signals from components to the PLC inputs, and you do the electrical connection. So basically, you build the same system as in reality, but then these signals, input and output signals in the PLC component in Simumatic, will be read and write from the real PLC or a soft PLC that you have programmed. So this is how it works, and this is what we can see here is actually when you go the next step, and you keep using your regular software. I mean, if you are using Allen Bradley or Codesys or Siemens, you program your PLC. If it's soft or real PLC, it doesn't matter. You program it with the tool you are used to program it, and then Simumatic will connect to that controller and fake the hardware. So it's gonna write in the input memory and read the output memory. So your code will be executed as with the real system.
Now I see at the top of the screen, and I'll try to describe this for the audio audience. On the left, we have Simumatic, and we got conveyor, and this is different conveyors. And on the right, we have TIA portal with some code in it. And you're saying you can connect both to a real S7 as well as use PLC
Yeah,
Sim. Is that correct?
yeah. I mean,
And
you can connect to a logo, to a 7, to a 1200 or 1500. I mean, uh,
okay, and on the bottom we have again a different system on the left, which is Simumatic, and on the right it looks like CCW.
no,
And I
that's
know.
I think it's called this, but yeah,
Oh, is it
it's
Codesys? Okay,
yeah,
it's a
that's
little
good.
small for my old eyes. But in any case, I believe you said one of the reasons that CCW came up in my mind was that I believe you said it works with the CCW simulator.
Yep.
So for those who don't know, I mean, Studio 5000 and Emulate 5000, very expensive products if you don't already have them. The CCW with the simulator is limited, but that is free. We
Yep.
covered that. We actually had the CCW product manager on the podcast last year, and we've covered that over at the Automation blog. But for the Allen Bradley side, that's one thing. And of course, Codesys is very popular as well. We've had them on, and it's good to know that it works with them as well.
Mhm. Yeah, so we don't want to replace the tools that engineers are using now. What we want to offer them is the way to digitize or virtualize the equipment they are programming. So basically, they do the same work as before, but instead of testing it against the real system, they can test it against a virtual system.
That's excellent. Awesome.
Yeah, and that's why it's very important to understand that the model is running in real time, because it's as all programmers know, you really need that real time thing. So your timers and all your delays and so on work as expected. So the signals need to come in a proper order and a time. And this is what we offer with Simumatic. So you can trick it, you can increase a little bit the speed and lower it a little bit, but you are aware of that, and you have to do it in purpose, just because maybe it's not going to affect your code.
Mm.
And then the same with the robots. I mean, you don't program a robot in Simumatic. We connect to robot controllers. In this case, we connect to virtual robot controllers. Almost all robot manufacturers offer a tool to program the robots. And those tools usually offer, or almost all of them, offer the soft controller, yeah, virtual controller that runs in your own computer.
Mm.
So you program the robot, download the code to this virtual controller in your computer. What Simumatic does is connect to this virtual controller and can mirror the robot position. So the benefit with that is that you can interact between the robot and other equipment that maybe is controlled by a PLC. And you can actually very easy interact between robots of different manufacturers. So what we are seeing in the screen is in the left side, we are seeing ABB's Robot Studio, and in the right side, we are seeing RobotDK and a Fanuc robot. Actually, in Simumatic, you can have a system where you have both an ABB robot and a Fanuc robot interacting with each other, something that you cannot do in none of those Fanuc or ABB software. So we offer this platform independent or manufacturer independent environment where you can add even PLCs of different manufacturers to the same system and control different parts. So Simumatic will do the magic and connect all these different components in the model to each corresponding software.
Excellent.
And then on top of that, we can do more stuff. So the platform is so flexible, so you can play with IoT stuff. And industrial IoT is growing a lot. We are seeing a lot of PLC manufacturers integrating MQTT, for example, in the controllers. So you can interact with IoT equipment. You can model IoT equipment as well in Simumatic. So then what we are seeing now is just a mobile app controlling the model in Simumatic, but basically, because it's using MQTT, you could control it from Codesys or TIA Portal as well. So you can use industrial equipment and add different kind of components to the system. And finally, this is just a cool thing, you can use Simumatic to teach other kind of programming, like Python, for example. So that the flexibility that our platform offers allows you to basically interface your model with anything you want. So we can do it with Arduino, MQTT, any kind of PLC or robot. And that is because our gateway, or the piece of code that makes the connection between the model and third-party hardware and software, that is open source. And I think it's good to mention it because we don't want to limit the connectivity of our platform. So if you want to connect it to something that we haven't done it yet, you can actually do it by yourself. So you can build a bridge between anything and Simumatic.
Now, just for the audio audience, some of the logos on here are Allen Bradley, Rockwell, Siemens, RoboDK, Beckhoff, Fanuc, CodeSys, Universal Robots, MQTT, Andrino, and I think I got an ABB and Simumatic. So I know the audio audience can't see that, so I just wanted to rattle those off.
Yeah. So I don't know how are we doing with the time.
Yeah, we're getting pretty long, but if you want to keep
Yeah.
going, we can.
Yeah, I mean, I just wanted to mention that you can build whatever you want. So to our customers in the both in the industry and education, we say that they set the limits. We offer inspiration with content that we create and we publish, and they can build from anything that is fictitious or prototypes to digitize existing products or existing systems, like what the ones that we are seeing here. One of our partners is SMC, for example, and they are digitizing all their catalog of educational labs. So the digital version of them, it works basically exactly the same as the real ones, and actually can be run with the same PLC program that the real ones, and that offers all these possibilities that we mentioned before. So we are seeing here in the screen two different stations that have different kind of equipment, pneumatics, electronics, and so on. And well, you can learn a lot with this kind of equipment.
Yeah, for those who don't know, SMC, I mean, most people think of SMC as pneumatic type
No,
devices, but they also make a large number. They have a very large catalog of training
yes,
for large colleges and whatnot of
yeah,
training stations that can be they can be all connected together to make a massive production
yeah.
line.
I mean, and this is still uh, being experimented or tested by institutions. But as you know, you can once you set up different stations together, you can introduce a MES system, um, plan production, and all this stuff. And basically, for the virtual model, all this is transparent. Even the HMI, I mean, if your PLC belief is connected to a real thing, even
Hmm.
if it's connected to the virtual thing, the HMI will work. The MES system connected to different PLCs will believe what this PLC is seeing, so you will be able to change recipes, plan your production, or whatever, and all that against a virtual system or production line. So it offers a lot of possibilities. And just finishing, I just want to mention that we have what we call a Simumatic Academy. And as we say before, anyone that wants to try our platform can just sign up. You get 1 month for free to test all the features. You get free access to Simumatic Academy, where we have a lot of courses from how to integrate Simumatic with different software and hardware, or how to build your models and so on. So uh, again, feel free to play with it and use the forum to ask questions on whatever you want.
I was going to ask that, so good. I'm glad you covered that.
So yeah, that was basically that what I had prepared, Shawn.
Now, if somebody has a question, like they're looking at and getting this for their staff and their maybe they've already tried the 30-day free trial and they have a good handle on how it works. They've gone through some of the tutorials and they want to maybe set up a meeting to talk about implementing it in their company. Who would they contact?
Now we have a button in our website. If you go to simumatik.com, you have a button in the top corner, top right corner, which says book a demonstration. So they can schedule a meeting with us, and we can talk about the needs. We can discuss about their experience. We can talk about potential collaboration and so on. So they can use that and book a meeting. We have different slots every day, so it's the easiest way to get in touch with us if they want to have a meeting. Otherwise, just use the contact form like in any other website and send us an email.
And for the audio audience, it's simumatik.com. Simumatic. And well, Mikel, I really appreciate you coming on the show and bringing us up to speed and telling us all about your product. It's very interesting. I enjoyed the show. I hope our viewers and listeners do. And I just want to thank you for taking time out of your busy schedule to do this.
Thank you, Shawn. Thank you.
Well, I hope you enjoyed that episode. I know I did. I can't wait to get my hands on Simumatik and try it out. But with that said, I really want to thank Mikel for coming on the show and giving us all that information about the software and a demo and the slides of different ways it can be used, including VR. I thought that was so cool. And with that said, if you're watching the video edition, please consider giving us a like and a sub. And if you're watching the audio only edition, please consider giving us a 5-star review so we can broaden our audience and we can find new vendors to come on the show. With that said, if you're looking for my affordable automation training courses, you'll find them over at theautomationschool.com. And of course, you can follow me and optionally support our work by going to automation.locals.com. With that said, I want to thank you for watching and wish you all a very safe, happy, and healthy week. And until next time, my friends, peace.